Half a day students, today we're going to be going over solving quadratic equations using the quadratic formula. You have already watched videos about this on Khan Academy, but a lot of students said it was confusing, so we'll just go over it again. So solving quadratic equations with the quadratic formula is one of the ways to solve quadratic equations. The other way we've learned was by graphing and finding the x-intercepts, right, where we graph and then we find these x-intercepts. As I mentioned in the last video, solving by graphing is not effective as when you're graphing by hand, you're not able to always come up with something nice, and especially if it's a decimal, it becomes really difficult to find. The quadratic formula, which was developed by the Greek mathematician Pythagoras, it is a formula that will work to solve any quadratic equation. So this works for quadratic equations in standard form. We have this x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's important you make sure that everything is over 2a. And basically you just identify a, b, and c, plug it into the quadratic formula, and evaluate to find your solution. This is probably one of the formulas that you'll be using the most throughout your years of mathematics, so you should memorize it. Now we're actually going to try using the quadratic formula. First, I need to check that my equation is in standard form, so it's in order from x squared x on the number, and it equals to 0, so it's in standard form, so I can use it. I'm going to first identify my a, b, and c. And because there is no number in front of x squared, the coefficient is understood to be 1, so a is equal to 1, b is equal to 9, and c is equal to 14. Next, I'm going to write out my quadratic formula. Again, I always suggest, even though I'm not collecting your work for certain assignments, I suggest that whenever you are working, you write out the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, and everything is over 2a. From there, I'm actually going to substitute in my values of my variables. B is 9, so I have negative 9 plus or minus the square root. 9 I'm going to keep in parentheses. 9 squared minus 4 times A times C. Just plugging those in all over 2A. And A is 1. There we have it. Next, I'm going to follow the order of operations using PEMDAS and evaluate this. So the first thing is parentheses, but it works for any grouping symbols. This radical right here is actually a big grouping symbol. So I'm going to evaluate everything inside or under my radical first. We call this the discriminant, and we'll get into more of that later. So we're going to actually just copy the rest of this first, square root of something over 2. So 9 squared is 81 minus 4 times 1 is 4 times 14. 4 times 14, we have 14, 28, 42, 56. So 81 minus 56. Find that again one more time. Plus or minus square root 81 minus 56. We have 11, we got about 1, 25 over 2. I know the square root of 25 is 5, so I have negative 9 plus or minus 5 over 2. From there, when I see this plus or minus, this basically tells me that I'm going to have two different answers. One's going to be x is equal to negative 9 plus 5 over 2. And another answer is going to be x equals negative 9 minus 5 over 2. So I'm actually just going to evaluate these both separately. Negative 9 plus 5 is negative 4 over 2, which is negative 2. So that's one of my answers. Over here, negative 9 minus 5 is negative 14. Over 2 is negative 7. So I have two answers -2 and -7. Trying to do the same thing again using the quadratic formula. We're trying to solve 2x squared minus 3x is equal to 8. You should be able to notice by now right away that this looks weird, and that's because it's not in standard form. The first step is always to put it in standard form, so I'm actually going to subtract this 8 and move it to the other side. So we have 2x squared minus 3x minus 8 is equal to 0. And since it's now in standard form, I can identify my a, b, and c. A is 2, b is -3, and c is -8. From there, I'm going to write my quadratic formula again and substitute in my values. So x is equal to -b plus or minus square root b squared minus 4ac, everything is over 2a. From there, I'm going to substitute in my values. So b is -3. Since I have negative 3, it's going to become +3 plus or minus square root of b squared. Always be sure to keep your b in a parentheses. So we have -3 squared minus 4 times 2 times -8. Everything over 2 times 2. Again, I'm going to evaluate the interior of this radical first. We have -3 plus or minus the square root of -3 squared is -3 times -3, which is +9, minus 4 times 2. So we have -4 times 2 is -8, times -8 is going to become +64, everything over 4. From here, I will simplify that. So we have -3 plus or minus 9 plus 64 is 73 over 4. So in higher mathematics, so in algebra 2 and up, you would actually just simplify your radical and you can just leave your answer as that. But in algebra 1, we'll actually just convert it to decimal. So I'm going to split this up into two different equations. So I have two solutions, right, because of that plus or minus. So one solution is going to be x equals to -3 plus the square root of 73 over 4. And the other one is going to be x is equal to -3 minus the square root of 73 over 4. If I was to find the approximation of each of these, the first one would be 2.89, and the second would be -1.39. And just be careful when you put it in your calculator because you'll have to do the top first, so -3 plus the square root of 73, and you'll have to press equal and then divide it by 4. Either that or use parentheses. So you have a different type of question. So now instead of it asking me to solve, it's asking me to find the x-intercepts of the graph. So we're calling the definition of an x-intercept. So an x-intercept occurs, right? So if that was our graph, an x-intercept occurs when y is equal to 0. So when y is equal to 0, we're going to be left with 0 is equal to -x squared minus 2x plus 5. And basically, this is looking like a quadratic equation that we're going to solve again. So when they say find the x-intercepts, that just means find the zeros, right? Which is what we've been doing this entire time. We're just solving this quadratic equation where our equation is equal to 0. So we're just going to be doing the same thing, but they're asking a different kind of question. From here, I'll identify again my a, b, and c. A is equal to -1, b is equal to -2, c is equal to 5. Plugging it in, x equals -b plus or minus square root b squared minus 4ac, everything over 2a. Okay, so we have -2 becomes +2 plus or minus the square root of negative 2 squared minus 4 times a, negative 1 times c, 5. Everything over 2 times negative 1. Evaluating, we have 2 plus or minus the square root of negative 2 times negative 2 becomes 4. Negative 4 times negative 1 is positive 4 times 5 is positive 20. Everything over negative 2. So I'm left with 2 plus or minus the square root of 24 over negative 2. From there, again, we have two different answers where x is equal to 2 plus root 24 over negative 2, and another one where x is equal to 2 minus root 24 over negative 2. Approximating both of these using a calculator, I'm left with negative 3.45 and 1.45. So basically, if these two were to be graphed and it was something, it's negative, so something like this, my x-intercepts would occur at negative 3.45 and 1.45. If you wanted to check it, you can use a graphing application and graph this equation. You should have these for your x-intercepts. Now we're going to be looking into the discriminant and its applications. So looking again at the quadratic formula, again, this is going to come up all the time now. So we have quadratic formula used to solve equations, quadratic equations in standard form. So the discriminant is actually the number in, or this little expression inside my radical, so underneath my radical. The discriminant can actually tell us how many solutions a certain equation a certain quadratic equation has. So one option is going to be when b squared minus 4ac is greater than 0, meaning to say it's positive. Another would be when evaluated b squared minus 4ac is equal to 0. And another when b squared minus 4ac is less than 0, where it's negative. So we'll look at graphs of 3 different possibilities. So when b squared minus 4ac is greater than 0, it can either be open up or down, but my parabola will pass my x-axis at 2 different points. Okay, where they're like, so we have 2 different x-intercepts, and thus we have 2 solutions. When we have only where equal to 0, it means to say that it might only touch the x-axis at one point, where my vertex is at the x-axis. And so I only have one solution. The last would be b squared minus 4ac is equal to 0. What this would actually look like is basically where we have a quadratic equation, a parabola that doesn't even touch my x-axis, and where I'll have no solutions because I have no zeros. So for the next examples, we'll actually be using the discriminant to find the number of solutions to certain quadratic equations instead of finding the actual solutions. So find the value of this discriminant and use the value to tell if the equation has 2 solutions, 1 solution, or no solutions. So looking at this first one, a is x squared minus 3x minus 4. It's in standard form, so what I'm going to do, it's equal to 0, right? So what I'm going to do first is identify my a, b, and c. So here we have, since there's nothing in front of x squared, it's understood to be 1. B is equal to negative 3. C is equal to negative 4. My discriminant is b squared minus 4ac, writing that here. Okay, plugging this in, we have negative 3 squared minus 4 times 1 times negative 4. Evaluating this, negative 3 times negative 3 is positive 9. Negative 4 times 1, negative 4 times negative 4 is positive 16. So my discriminant is equal to 25. And since my discriminant is positive 25, it's positive, it's greater than 0, I know I'm going to have 2 solutions. So even though it's not asking me what my solutions are, I know that I should have 2. Looking at this next one, I have negative x squared plus 2x minus 1. First step, now I identify my a, b, and c. A is negative 1, b is 2, and c is equal to negative 1. We have b squared minus 4ac for our discriminant. So we have 2 squared minus 4 times negative 1 times negative 1. Evaluating this, I'm left with 4. Negative 4 times negative 1 is positive 4 times negative 1 is negative 4. So my discriminant is now equal to 0. So I know that I'll have 1 solution. I don't know what it is, but I know there's only going to be 1. Looking at this last one, I see that a is equal to 2. B is negative 2, and C is 3. Again, my discriminant, b squared minus 4ac, is equal to 2 squared minus 4, or negative 2 squared, I'm sorry, minus 4 times 2 times 3. Negative 2 times negative 2 is positive 4. Minus negative 4 times 2 is 8 times 3 is 24. So I'm left with negative 20. So my discriminant is now a negative number. So because if I was to use the quadratic formula and plug this in, I would have a negative inside a radical, which I could never do, right? You can't take the square root of a negative number at this point. So I'm going to have no real solution. Looking again to a different type of question they could be asking is to find the number of x-intercepts of the graph of the function. This is the same thing again, they're just relating it to the graph now. Basically they're asking if this function was equal to 0, how many solutions would I have? How many zeros does this quadratic equation have? So what I'm going to do is equate them to 0. We have x squared plus 2x minus 2. So x-intercepts occur when our y is 0. So we have is equal to 0. From there, I identify my a, b, and c. A is equal to 1. B is 2. And c is negative 2. Doing the same thing again. B squared minus 4ac. We have 2 squared minus 4 times 1 times negative 2. My discriminant is equal to 4. Negative 4 times 1, negative 4 times negative 2, plus 8, that's equal to 12. So we have 2 solutions that are equal to 0. Thus, we can answer the question by saying that we actually have 2 x-intercepts. Looking at this next one, we choose a different color here. Let's go with purple. Okay, so A is 1, B is 2, C is 1, B squared minus 4ac minus 4 times 1 times 1. We have 4 minus 4 is our discriminant, so we have 0. And so since my discriminant is equal to 0, I have 1 solution. So I'll have actually 1 x-intercept. And when we only have 1, it's actually occurring at our vertex. Looking at this last one, I have a is equal to 1, b is 2, and c is 3. Again, b squared minus 4ac. We have 2 squared minus 4 times 1 times 3. 2 squared becomes 4. Minus 4 times 3 is 12. So 4 minus 12 is negative 8. My discriminant is negative, so I'll have no real solution. So that actually tells me I'm not going to have any x-intercepts. So no x-intercepts. You can say no x-intercepts, 0 x-intercepts, whichever. Just answer the question that they do ask you. So as you notice, we're just basically doing the same thing over and over again. We're using our quadratic formula and our discriminant in order to tell us a bunch about our quadratic equations.